Doing today, we're going to be talking about doubling dimensions. Okay, so I've done the homework, I've recorded it, and it's on the VIP site. Please go and check. If you have problems, you can ask on Monday. Okay, there's obviously no school tomorrow for the Founders Day thing. So, when you're talking about the effects of doubling dimensions on surface area and volume. Now, when we did doubling dimensions in our area, what were we able to find? What did we be able to see then when we doubled the dimensions in an area? How much did the area increase by? 4. Okay. So we were able to say that a ratio from first part, okay, we had a 1:4 ratio for area, okay, because when we doubling our dimensions, we go from 1 to 2, but because it's area, we're going to be squaring it. So it's basically it's 1 to the 2 squared, okay, for area. So if we're doubling, okay, doubling volume, what do you think it's going to be? What do you expect it's going to be? It's 1 to 2, because we double it to the power of what? What do we do? What do we do with volume? What cubed? Okay, so 2 to 3 is 8. Yes. So for volume, we should be expecting, if we double the dimensions, the volume should increase by 8. Okay. So let's have a look, and then let's look at this. So figure A is a cylinder, original cylinder. Figure B is dimensions has been doubled. Calculate the TSA of the cylinders. I'm just going to cut this quickly. Move it there. We go. Okay. So let's have a look at the first one. Let's look at A. Okay. So we're going to find the total surface area. Okay. And we're going to say total surface area of A is equal to, now for my class, we already said it's 2 times my base shape, my base area. Okay. And if you're talking about a cylinder, what is my base area? What shape are we talking about? A circle, yes. Plus the perimeter of my base area. Now, what's another word for perimeter of a circle? Circumference, yes. And then we're going to multiply it by our height. Okay, so the height again, okay, the height is the thing, okay, that makes it into 3 dimensions. Okay, so we talk about our base area here, okay, and then there's a base area, and then our height value is the thing that makes it into a prism into 3 dimensions. So we're going to plug in the thing here. So you can say 2 times the area of a circle is pi r squared. What is the radius of this first one, A? 2. Yes, because the diameter is 4. So it's going to be times 2 squared. Then we're going to add, okay, the perimeter of the circle is now circumference. Formula for circumference is what? Pi times the diameter. So in this case, it's pi times 4. Okay, and my height is going to be what? 5. Yes, very nice. So plug it in your calculator. Quickly tell me what you get. Quick sticks, quickly before I get mine out. There you go. You see where to go? It's the perimeter of our base shape. Okay. Pardon? 28 pi, which is what? 97.96. And what's my unit? Squared. Very nice. Okay, centimeters squared. Very important. Oh, no. Okay. So, when we're going to have a look at the second one now. Okay. Okay, so I'm going to start it now. Okay. I'm going to work it over here. So I'm going to do it in a different pen color so you can see. Okay. So the TSA, total surface area of B, okay, the bigger one now, is going to be equal to what? It's 2 times my base area, so it's that green circle, the base area, there, plus my perimeter of my base area multiplied by my height. We plug that in, we're going to get 2 times pi, and my radius here, my diameter is 8, so my radius is going to be 4. So it's 4 squared. Okay, then we're going to add the perimeter, so it's pi times 8, okay, multiplied by my height is 10. So do you see, the diameter has gone from 4 to 8, my height's gone from 5 to 10, so we've doubled our dimensions, okay. So we plug that in, what we're going to get? 112 pi. Okay. 12 pi. Which is equal to 351. 86. Okay. So have a look here. What do we see? Okay. What's the volume? What's the area? Okay, of B. So so A, okay, has an area of 28 pi, okay, and B has an area of 112 pi. Is that correct? Okay, because then what you've done there, usually because you're using pi, you haven't said multiply by the pi value. You can't say pi 4, you have to say pi times 4. So check that in your calculator. Okay. So if we have to simplify this, do we see it is, so 112 divided by 28 is going to be 4. 1, 2, 4. Okay, so do you see that? We've doubled the dimensions and therefore the area has increased by 4. Okay. So this is something that we did in the previous chapter. Okay. So you know how to do area. So let's work now with the volume. Can I move? So what conclusions can we make about this, therefore? Okay, the ratio of the new TSA to the original TSA. A to B is 28 pi to 112 pi. So what can we see there? It's going to be a 1, 2, 4. Now you should already know this. Okay, you double the dimensions in area. Your area is going to times by 4. It's going to increase by 4. Okay, you got that? You understand? Yo, lots of blank faces. Okay, so now calculate the volume of the cylinders. Okay, calculate the volume of the cylinders. Now, I got it here. So we're going to work out the volume. The volume, we said, was equal to my base area times my height. Yes. Times my height. So, in this first one here, the volume of A is going to be pi times what? 2 squared multiplied by 5. Okay, so we should get there 20 pi. Very nice. Okay, we're not going to round off quite yet, so just keep it as 20 pi for now. Okay. I'm just going to write in here 62.83. Okay. So then we're going to look at the volume for B, the same thing, but now it's going to be pi times 4 squared. Yes, very good. And my height is 10. Okay. So what's that going to be now? 4 squared is?
160 pi.
There we go, 160 pi. Okay. So we've got 160 pi for number B. Now, can you already see what it's going to be? Do you already see the ratio? We talked about it already. What's it going to be? $502.65. Okay, so let's look there. Okay, so the volume of the cylinders is going to be 20 pi for A. Okay, I'll go back now. And B is going to be 160 pi. Okay, have a look quickly, have a look. Okay, so if we round, okay, so the ratio for the new volume to the original volume, okay, the new volume is going to be 160 pi to 20 pi, okay, A and B, okay. So do you see it's going to be an 8:1 ratio, okay. So if you have a look here, if we say, what is 20 pi? 20 pi is equal to approximately 20 times pi. We're going to say 62.83. And then 160 pi, okay, it's going to equal to 502.65. Now, if we take that and put it to each other, have a look here. So if I'm working with B to A, so the new one to the old one, so we have 502.65 to 62.83. Okay, to find the ratio, we divide this by the smallest one. So it's going to be 1. It's going to be 1 is to what? So is it going to be exactly 8? 502.65 divided by 62.83. Okay, so do you see we have here 8.000159116. You guys see that? Okay, so why are we coming up with this error? We know it's a 1 to 8. Why? What's all this for? What's that from? We rounded off too early, exactly. Okay, we're using rounded values. Okay, so my answer is not going to be exact. If we use 20 pi, that's not a rounded answer. Okay, so what deductions can we make about doubling dimension? Okay, what deductions? Anything? What can you tell me? Okay, we can deduce that for area, okay, if we're going to double if we double the dimensions in area, okay, we're going to multiply it by what? 4. So remember, look, 1, 2, 2. So we want to double the dimensions. So the dimensions now increase to 2, from 1 to 2. Okay. But now let's put it in this. Okay. I have x. Okay. I want to double x. What do I have to do? Times by 2. 2x. But what do we know already? This is area. Okay. So you have to square the whole thing. So my area is going to be x to 4x squared. Okay. A 1, 2, 4. If we have volume, okay, we're going to take x to 2x. We want to double the dimensions, okay. But what do we know? Volume always, what's the units for? It's cubed. So it's going to be cubed. So it's going to be x to 8x cubed. Okay. 1 to 8. So the surface area of the enlarged prism, okay, is 1 to 4. The volume of the enlarged prism is 1 to 8. Okay. So if we do a bit of, like a little bit of a segue, if I want to triple my dimensions, okay, triple my dimensions. Okay, so if I say that now, what's going to happen? I'm going to be 1, 2, 3, but for area it's squared, right? So 3 squared. So if I triple my dimensions, triple area, I'm going to have 1 to 9. If I triple my volume, 1, 2, 3, triple my volume, but volume is cubed, okay, it's going to be, the volume is going to increase by 27. Okay, so they all range in proportion to each other, but we don't do that there. Okay, we just do double the dimensions. So for the surface area of enlarged prism, it's 1 to 4, and the volume of the enlarged prism is 1 to 8. Okay.